Recording in progress. All right, here we go. So again, to get this set up, I have right here, I started, usually we want something to start off our script, like pressing a key or when the flag is pressed. So usually I'm going to use one of these two blocks in my script. And I chose the when flag is clicked. And I want to get my my sprite here to count up to a certain amount, let's say up to 10. And to do that, I got to use a variable to keep track of what numbers he said so far. So I need a variable. And again, your script will come with a my variable. So we want to, from the variable section, we want to right click on my variable and rename it. I recommend calling it count. When you write complicated programs, you're going to put a considerable amount of thought into what you call your variables, because again, it directs how your code flows and how you work with your code. So choosing good names is important. So do put some thought into it. So I'm calling that one count. And then the first thing I want to do is I want to set that count. Now it comes with a set count to 0. When I count, I don't usually go 0, 1, 2, 3. I start counting at 1. Now, many computer languages start counting at 0. We'll get to that later when we talk about lists. But for now, I'm just going to set the count to 1. So I'm just going to change that 0 to a 1. And then otherwise, if you didn't already get it, you want to grab a repeat block and put that in from the control section. And from the looks, you want to grab a say hello for 2 seconds and throw that in. So your code should look something like this so far. So right now I've got the repeat set at 10, and I said I got it to say 1. Now this is just going to say 1 10 times in a row. I need that to update. So what I want to do is, instead of putting a literal 1 per se, I want to go back to my variable and grab the variable called count and put it in place of the say 1. So now it says say count. So what's going to happen right now? Well, what is count at the moment? 1. It's 1. I'm not changing that anywhere. So what'll happen right now is he'll just say 1 10 times in a row for 2 seconds each. So next thing I need to do is update that. So I want him to say it, and then I want to update it, and I want to repeat that update. So in my loop, I want to change after the say count by 1. So now what this will do is it count starts off at 1. We jump into the repeat block. He says 1 for 2 seconds. It immediately jumps to the increase count by 1 or change count by 1. And then it goes back into the loop and says the next number, which is now going to be 2. So if we run this right now, and I'm going to change the 2 seconds to 1 second. So we'll run a little bit quicker. I should be able to hit the flag, and he should count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 10 seconds. So again, now I can easily make him count to 100 or, whatever we need to. We can change the delay on that with the 4 blank seconds. You could play around, see what would happen if you just did say instead of say for blank seconds, just to check what that does. Order of operations, sometimes when you're going through a loop like this with a variable, the change in the action might happen in a slightly different order depending on a situation. So it's possible a slight variation on this code right there. Let's just copy this. Is there might be instances where you do want to start at 0. Other stuff is going to happen while it's 0. And then when he finally gets to count, since you want him to count at 1, you would do the change from 0 to 1 and then start saying it. Okay.
That's
yeah, and it can go right for this particular example, it doesn't matter. Both blocks of code will work the same way. But in more complicated situations, there are some times where one order might be more beneficial than another when we're playing around with multiple variables that act in sequence. Okay, so is the first way the better way than the second way? The answer is no, they're just 2 different ways. And in some situations, there's pros and cons to both. In this situation, they do the same thing. All right. So again, what's the point of a variable? What is a variable? A variable is a placeholder for something. That's all it is. It's like a garbage can. What goes in a garbage can? Well, we put garbage in a garbage can, but we could really put anything in it. Like I have a garbage can at home that I keep some tools in, and the garbage can has a handle, and I carry it around like a toolbox. Okay. What kinds of things in a computer could we have a placeholder variable for? Well, numbers for sure, right? Is there anything else we might use?
Maybe an operator? Like,
Yes, and some, yes, we could. All right, so operator, that's a good point. Let's write this down. Some options. See, somewhere I have a notebook. Go notebook. Right here. Tablet went off. Come on, you can do it. There we go. All right. So again, variable, essentially we could say it's a placeholder. Or, well, so far we have the idea of a number we could put in there. You mentioned an operator, and I'm assuming by operator you mean something like a plus or a minus or a times or a divide. Scratch has some other ones like mod. Other languages have other operators that are out there. And these right here, more generally, are called characters. Oops, not with a G, with a C. Characters. And on a computer, you have access to a ton of characters, right? On the keyboard, you have A, B, C, and so on. You can hit shift and you can capital A, B, C, and so on. A comma is a character. A period is a comma. Are there other characters that the computer knows about that aren't on the keyboard? The answer is yes, like pi. Anybody know where the pi symbol is on their keyboard? Right, what kind of pi? Then yeah, so the number pi, right? So I'm thinking this guy right here, pi. When I'm in a word processor, there's special characters I can get access to, and sometimes I can use those depending on the environment that I'm in. So in most computer languages, you have way more characters than just the keyboard. So if I go like into Google Docs here, so let's see, what data types are available in Scratch? So that's kind of what I'm addressing right here. And I'm going to say character is one type. And examples of characters are things like A, B, C, dot, 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 capital A, capital B, capital C. Keep going. And then there's all kinds of other characters in the keyboard, like this one and 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 this one. Those are all characters. And if I go to the special characters, insert special characters, then I can choose from a whole bunch, like one of my favorites, pi. And there's a whole bunch of pies here. I like that one today. And just clicking it puts it in there, I think. Now, do you always have easy access to these characters? And the answer is it depends on what application that you're in. Like when I'm typing an email, my email doesn't have a list of special characters, but check this out. Bring up a new browser window on your computer and search for pi, PI symbol. So you'll get a whole bunch of stuff. And like in this first one right here, there is a pi that I can then highlight with my mouse, and I can copy it, and then I can paste it in different places that'll accept it. So I'm going to go over to Scratch and see if I can put it in there for fun. So where's my Scratch script? Over here. So after he says all that stuff, I'm going to have him just do a say, and then I'm going to delete that, and I'm going to try pasting that in. Let's see if it actually works. Let's make the count quicker by going half a second. Run it. Hey, it said pi, holy crap. And again, I was able to grab that character and paste it. And two things had to happen there. One, when I copied it from the web, the Scratch system had to recognize that particular character. So there are a set of characters, what's the right name for them? I think they're called HTML entities, and they are tons of characters that you have access to when you're doing anything related to the web that all web browsers are supposed to recognize. And that includes like foreign language characters like Cyrillic or Chinese or Japanese, kanji, and then math, special math symbols, Greek letters, all kinds of things like that. And if you search on the internet, let's see, I think what do I call them? Web, I think they're called web entities, maybe. HTML characters, glossary. There's a couple sites that had a really good list of them. W3C. Let's see the site I was looking for earlier. Let's try this one. Some of them have short codes that you type, like an and with some letters followed by a semicolon, depending on the computer system you're working in. And in others, they just appear. So like this symbol right here, I should just be able to copy and paste that. That's also known as the section symbol. It's probably got some other names. And I can probably get my sprite to say that too, just by putting it in here. Can you take any special character you find online and have it display in a language like Scratch? The answer is sometimes it doesn't work so well, but it works for the common ones, and there are hundreds and hundreds of common ones. Yeah, it didn't mind that one. It set it up there. So we have numbers that we can use. We have characters. Now, really, a number is a character in a sense. So for example, we have the sprite count 1 and then 2 and then 3 and then 4. So individual symbols like this are called numerals, or actually, I'm lying, they're called digits. Bless you. And how many digits do we have normally in English in most languages, but not all? There are 10 numeric digits. 0, 1, 2, 3, 4, all the way up to 9. So those are the single characters we use to make up our numbers. And then we put them together in more complicated ways. So for example, like 162, the number for this class are 3 digits together, and they're not just a 1, a 6, and a 2, right? It's a 100 and a 6 tens and a 2. Right, so our number's a little more complicated than that. And the computer has to recognize that that's not just a 1 followed by a 6 followed by a 2, that we mean that to be 162. Okay, so that means in the background of Scratch, it has to, again, differentiate between the word 162, 3 characters together, and the number 162 things. Okay, so those are 2 different ideas. So as far as variables go, variables are placeholders for things I'm going to call data types. And those data types could be a number. They could be more generally a character. Characters include operators, but operators are special in computers. And if I put a bunch of characters together, we might call that a word. In computer language, they call that a string. So a string is a collection of characters. We humans are used to breaking up our strings with spaces. So we can say, okay, this particular string, oh, there's a space. That is a word. But as far as the computer goes, there's really nothing special about a space. It's just a character that takes up space, but we don't really see it, but it's there. So space is also a character, a special one. So as far as the computer goes, a string could be a word, but it could be a sentence. It could be a paragraph. It could be a whole book inside a single string. And then, so again, major types are number, character, string. So let's label these as 1, 2, 3. Another special data type I mentioned, I think last week, is what's called a Boolean. And a Boolean is either true or false. Now, numbers a little fishy because it turns out there's a lot of different kinds of numbers, and we, depending on the number, we treat them slightly different. So for Scratch, the main two types of numbers that it knows about are integers. Let's get a new page for this. Numbers. So integers are like 1, 2, 3, 0, -1, -85. Right? Those are examples of integers versus let's call them decimals. And those are things like 3.14 or 2.5 or 1024.101 or maybe 0.00000006. Now, in our reality, we know numbers like fractions. Scratch doesn't deal with fractions very easily. We would have to combine integers with the division operator to make fractions. Okay, so that's a little trickier. So as far as Scratch goes, Scratch understands integers and it understands decimals. Fractions have to be treated special. They're not a data type Scratch works with on its own. And most computer languages, you have to add on a special package to deal with fractions. It's not an innate part of most systems. They do decimal and integer arithmetic by default. All right, let us try something else.